Okay, so as you mentioned, our whole mission is to help civilization transition from fossil fuels onto a sustainable economy. Okay, so how do we do that? Really, we've got three steps, quite simple: electrify everything. And then we have to get all of that electricity from renewable sources, solar and wind. And then the third part, which is really the missing piece, is we need massive amounts of energy storage. So that's what Qnetic is providing. So why do we need energy storage? Well, basically, supply and demand don't match. So from time to time, you'll have insufficient supply. And if we have enough energy storage, we can charge when we have sufficient power and then discharge when we need it. And this is called energy shifting. And you need to do this on the 24-hour cycle, which means we need a system that can discharge twice a day and can discharge for long enough that we can actually serve that 24-hour cycle. But today we have insufficient systems. Lithium-ion batteries, well, they degrade from the very first cycle and you have to replace them. Pumped storage hydropower is very good, but it just doesn't scale. You can't mass produce that. Flow batteries aren't efficient enough, so therefore they're expensive. And then things like gravity storage are just huge and take up a huge amount of material as well. By the way, these two things are actually mechanical storage. They're still considered maybe a battery, but they're mechanical storage, which is exactly what Qnetic is doing. So this is our vision of the future, where we have a Qnetic battery outside every town and city. So our product is these are little domes you can see. So underneath these domes is this. This is you're looking at the motor and generator and bearing system of our system, but that's above ground. What's below ground is this. So this huge Flywheel energy storage system. So what is that? It's basically a mechanical battery. So what we have, the black part is the bit that stores our energy, and it stores the energy as kinetic energy. It's basically a spinning element. And then we suspend that with a magnetic bearing, so we don't have any mechanical losses. And then we get the electricity in and out using a motor generator. So here you can see 100 of those systems connected to form a grid scale battery, responding to supply and demand of the grid. So we install it underground to make it intrinsically safe in the cheapest way possible. And we have this thin concrete skin to allow us to install it in the ground. And then we take in renewable energy from solar and wind and put that through a motor that converts that into kinetic energy. And then we accumulate the energy in the rotor. The faster it goes, the more energy we're storing. And we can hold that energy for a really long time because we have a vacuum inside the chamber and we have these magnetic bearings. That means we have no contact. And then to get the energy back out, we simply reverse the process, and the momentum of the rotor drives the motor and now acts as a generator, and we discharge the system. So it's actually beautifully simple, but actually very, very effective. Okay, so that's the product. What does it achieve? Three things. First of all, it's huge. The capacity of Qnetic is many times more than existing technologies. They're just a few percentage points of where we're going with Qnetic. So it's like the jumbo jet of Flywheel energy storage. The second thing is that it's super low cost in terms of capex, and also in terms of what's really important, which is levelized cost of storage. It significantly undercuts lithium ion. It's half the price of lithium ion. And the third thing that's most important to us is that it displaces fossil fuel emissions. Each system can displace 4 tons a day over 20 or 30 years of its lifetime. That's really significant. So this is the leadership team that's going to get us there. Myself, my background is product design and development. So I know about taking requirements and figuring out how to take a product from there to into production. My co-founder is the guy with the glasses. So his background is actually rotating machinery. He's an expert in this type of product, previously in gas turbines and then in wind turbines. And he's really the genius behind some fundamentals of Qnetic. And then joining us, we have Matthias and Malcolm, both very senior guys, one from the engineering background and working in renewables, and Malcolm from finance and business background. So we've really got quite a sort of powerhouse team behind us. And the market is exploding. We've got a market that's doubling every 3 years, and we're only 1% of the way through installing all of the energy storage that we need in the world. So if we jump forward a few years, 2030, we are intending to have about 1,000 units a year in production, which actually is not that many considering the demand. It's only a few percentage points of the total demand. And therefore, we need a big company to get us there. So we're expecting by that point, we're going to have a company worth over $1 billion. So we've got 2 major stages that we want to talk about right now. The Alpha 1 stage that we're funding right now, and then the Alpha 2 stage that we want to get funding for later on this year. Alpha 1 stage is our first prototype, and Alpha 2 stage is our big full-scale prototype that we're going to put into pilot sites and from that generate demand. And the Alpha 1 stage is fundraising right now. That's live on WeFunder. So we're about $750 million through our fundraise. And then for the next fundraise for Alpha 2, for the big scale prototypes, it's going to take about $5 million. So we're looking for VC funding for that right now as well. And finally, on recent news, we have filed our first patent not long ago. That covers the bearing systems. That's really important. And excuse me. We've raised nearly $750 million so far on our WeFunder, and we've got interest from several VC firms who are we're expecting an offer from soon. We've just built our 10% scale model that I'll show you in a sec, and we're right now hiring staff and moving to a new office so we can develop the product. So very finally, here's the 10% scale model, so you can get a feel of what it looks like as the system is charging and the rotor gets faster and faster. So what we need to do next is take that to the next level and build a full-scale prototype.